Children, one of the important concepts related to total internal reflection is understanding critical angle. Understanding critical angle. So just once you understand this critical angle, it will open the doors to understand total internal reflection. Once we understand total internal reflection, whatever things that we started in the beginning, we can do it easily. Children, one of the very important thing about critical angle is it is defined only when light travels from a denser medium to a rarer medium. So you can put this in your mind. It is always true, and critical angle is always defined only when light travels from denser medium to rarer medium. Already we have seen when light travels from a denser medium to a rarer medium, the rule of bending is the light bends away from the normal. Angle of refraction is greater than angle of incidence. What Snell's law suggested is sin I is proportional to sin R. So if you increase I, this R will increase. R will increase. So just to make things clear for you, let us suppose I have increased the angle of incidence. Say this is initial incident ray. Now I have increased the angle of incidence. You can see in this diagram, when compared to the initial light ray, now I have increased the angle of incidence. Automatically, the angle of refraction also increases. You can observe increase in angle of refraction. Now, if you continue to do this, you will find at one particular angle of incidence, the refracted ray will graze the interface and angle of refraction will be 90 degrees. So that angle is what is called critical angle. So it is an important question for you for board exam, an important formulae in intermediate formulae for many good questions in ray optics. So critical angle is defined as the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90 degrees. Children, if you want to put some math and write an equation, use Snell's law. Mu sin theta is constant. Now I will apply it here. Let us say mu1 is the refractive index of denser medium. Mu2 is refractive index of rarer medium. So I will write mu1 sin C is equal to mu2 sin 90 degrees, or your sin C is equal to mu2 divided by mu1. So this is the general expression for critical angle. Here is a tip for you. Always the value of sin theta is less than 1. So the ratio of mu2 by mu1 must always be less than 1. Whenever you are given two informations like mu1, mu2, lambda 1, lambda 2, wavelengths, v1, v2, you can always find critical angle with this short memory trick. C is equal to sin inverse of smaller value divided by larger value. So whatever two informations about refractive indices, wavelengths, velocity is given. So you can calculate critical angle by this. I will conclude with what is this TIR? When light is traveling from denser medium to rarer medium, and if the angle of incidence is greater than critical angle, this light ray will return back to the same medium, and this interface acts like a plane mirror. The entire light without any loss will come back to the same medium. So that is what is total internal reflection. So we started this class with some 4 naturally occurring phenomena, to begin with brilliance of diamond, then a mirage, then an optical fiber, and field of view of fish. All these 4 are because of this total internal reflection. And in my short span, I try to explain what a refraction is, what are the rules of bending. I touched upon what is Snell's law, what is refractive index, and how to use Snell's law in getting the expression for critical angle, and finally total internal reflection. So in the coming videos, we will elaborate on how that diamond shines brilliantly, what is the functionality of an optical fiber, how mirages are formed, and how could that fish can see only a world in circle. So keep waiting for the next videos to come, and more are there from our side.